Thanks everyone. Thanks everybody for coming today. We're going to have a very interesting discussion panel about the intersection of AI, data science, and life sciences. So we have representatives from all different backgrounds, ranging from nonprofits to private sector to different sorts of entities like that. So, well, big thanks to the New York Stem Cell Foundation to help us host this, and for New York Economic Development Council, NYC EDC for funding the LifeSci NYC Internship program. Let's we'll start it. Can everyone introduce themselves, and then we can go forward from there. Your current role, the type of work you do, things of that nature. Just introduce yourself. Let's start from the left.
Start from the right or the left.
Stage
All right.
left.
Yeah, stage left.
You know that means exit, right? I also find it weird that I'm on a microphone. I'm very loud, as some of you might have noticed. So I have a long name up there. Just call me Hamdi. That's fine. I am currently program director of the Merck Digital Sciences Studio. It is a collaboration across 6 different companies, 3 investors: Merck's Global Health Innovation Fund, McKesson Ventures, and Northbound Ventures, as well as Merck Research Labs, Microsoft, and New Jersey Innovation Institute. And it is an accelerator focused at the intersection of digital with drug discovery and development. Before that, I ran a nonprofit for a few years, helping scientists find co-founders, advisors, and investors. And before that, I was a PhD in chemical engineering, working on data and wondering what the hell to do with my life. So hi everyone, I am Dude.
Thank you.
Just keep going, it's on.
Hello? Okay. Hi everyone, so my name is Thahmina, and I am a data scientist at Memorial Sloan Kettering Cancer Center. I work in a computational biology research lab, and I'm still young. It's been 3 months, and my work is a project where I'm basically looking at MSK's cancer data and building a knowledge graph out of it, and then applying modeling on it. So hopefully being able to use generative AI. So you've heard all the buzzwords: GPTs, BERT, the large language models. Getting a model to understand the language of the genetic data, specifically in cancer data, just like the way it does when it's how it understands natural language. So it's a very exciting project. Actually, I'm super excited because this is what I've been looking for years, being able to do data science research full time, and also to be able to apply my own ideas, get innovative with it. So before that, I was actually in the industry for a year and a half. I was a data science consultant for a bioinformatics firm. Before that, I was working in Genentech. I was in a data engineering position, working on clinical data. And then before that, I spent quite some number of years working as a bioinformatician in academic research labs, in core facilities. I was working at Rockefeller University. I was working at Cornell. And my education is in bioinformatics. I got my degree at Hunter. So it was actually through this program, this internship program, where I got exposed to AI. I was working in a startup called Envisagenics. They used AI to do RNA therapeutics. And then that's how I delved into the data science field. I couldn't believe it that they were able to use this technology to, produce these drug predictions, or this technology is able to even do predictions on life science data. So I'm really happy. I'm very thankful to the program for helping me change or find my passion now. Thank you all.
That's on.
Are you being blinded by the projector?
A tiny bit.
It's not dim.
It's okay, I guess. I mean, I was getting used to it.
Get you some sunglasses.
Yeah. So, hi everybody, my name is Bianca Migliori, and I'm a principal data scientist.
It's okay.
So, I'm a principal scientist in data science here at NICEF. As you probably know, the New York Stem Cell Foundation, where you are all sitting now, is trying to find cures for most of our diseases over time. And what I am doing here is trying to help and do drug discovery to find some new ways to approach this topic. So trying to use data science combined with automation to try and highlight the phenotypes that there are for the diseases we are studying, and then try to revert that phenotype that we find using some drugs. So that of course entails a lot of computer vision, a lot of AI, and a lot of work with like polishing the data and like pre-processing, and of course a lot of the work which I'm very thankful for from all the biologists that have to run the assays and make them as precise as possible. Before that, I was a postdoc at NYU, and before that, a PhD student between Columbia University and Karolinska Institute. So I was doing academic research mainly in microscopy and of course data analysis. So I was building microscopes and then I had to analyze them. So I got more and more passionate about the analysis part compared to the building part. And that's why like I kept working with cells and like fluorescent imaging and then data, lots and lots of data. And before that, I was biomedical engineer, so I have a bachelor degree and a master's degree in biomedical engineering. And I was working for my master thesis at HST, so Harvard and MIT for science, health science and technology. And there I was working in a project with biorobots and tissue engineering. But there too, I was starting to image them and try to like characterize my structure and looking at fluorescent imaging, and then again analysis, video analysis, image analysis, and that's where like my path started and where like it kept going since then.
Hey, I'm Karl. I'm the executive director for machine learning at Schrödinger. Schrödinger is a biotech that IPO'd, I believe, in 2020. In this role, I oversee strategy, direction, and execution of our machine learning technologies. Mostly, I'm concentrated in for the drug discovery process, from hit finding through clinical nomination. My background is actually in computer science. I had very little understanding, knowledge, etc. of the life sciences before I started working. My first role at Schrödinger was building the backend for their web-based chemistry tool. From there, I understood what the shape of the data we actually have is. What is the actual stuff that we had and how we're underutilizing it. And that's how Schrödinger started to have a machine learning team.
That's very interesting, all of you working in kind of the same field, but like different paths to get there. So that's quite interesting. So I guess like if you guys touched upon it, how did you get interested in both life sciences and AI and data? Was it like just one experience, or was it just a collective experience that you saw like the future there and you really liked it? Was like, did you have an aha moment, like I really like this, I want to go forward? Anyone really could take that. It could just be I just fell into it and stuck with it, you know?
I just fell into it. That's some degree of it. Sorry to sound a little flippant, but like, I am wildly suspicious of people who are like, I have a 5-year, 10-year vision and I'm executing it perfectly. That means you're not being imaginative enough. You're not like risking failure enough. You're not having mistakes. Mistakes is natural, it's fine. I think I came into it because I spent a lot of time, programming on the side. A lot of my work would end up using it, and I was like, oh wow, like this is more and more useful for others. I guess I should practice this and try it. So it just kind of evolved in that sort of way for me. There are people who are more diligent and focused about it, but it's fine to be a little chaotic.
Yeah, so I think I mentioned before in the intro how it was through this program that exposed me to the field. So I was part of the first cohort, and I was working for Envisagenics. And I had a different role when I was interning at an engineering role, so I had to fix their Python code because it was producing wrong visualization of their sequencing data. But I was working alongside with the AI engineer that was, building the model, and they were very open. They were very generous enough for me to show me around and in terms of what they were doing, the developments, and it just inspired me. Because here I was doing this type of programming that didn't come near to what they were doing in terms of building out this end-to-end model that can, produce. I mean, at the time it was doing predictions, probably not the best accuracy, but they were still very focused compared to what the traditional method can do, and not to say anything about pharma companies or biotech companies, but it made me think at the time, oh, here you have these pharma companies and biotech companies trying to produce this drug that takes almost a decade, billions of dollars, and it's half working. But here we can rely on technology that can accelerate the pace, have it more focused on several candidates, and then the scientists in the lab, the experimentalists in the lab can go back and be able to synthesize something that's actually working. Because a lot of times what happens is that you have the traditional method will experiment for a drug, and when they do synthesize, it doesn't work anymore, or it's not actually working. So it just made me think about the future of the direction of how healthcare, how life science can be more impactful, and can be more, how we can take advantage of AI technology, or how we can use the technology of AI to do better science, especially in the drug discovery field, in the healthcare field. So it really motivated me to learn the data science, learn the field. So I actually signed up for a boot camp where I learned the mathematics and then more of the programming and how to apply it on the data. And then I just started to look for projects, and that's how I ended up in Rockefeller. I wasn't working on an AI project full time like that because of the pandemic and all that, but it still allowed me to get my hands dirty. Allowed me to see myself, what I was getting myself into. And then eventually I just started, I was really able to work on full-time data science project when I was a consultant. And now, even though I was doing data science as a consultant, I still wasn't thinking like one. I still wasn't thinking deeply, because in the industry you have to think broadly. And with research, I wanted to do research because I love research, and it also allows me to think deeply. So I kind of missed that aspect of it, and went back to academia, and here I am.
So, back when I was in high school, I was very undecided between medicine and technology. So there was this new degree that was combining the two, biomedical engineering. So that's what I picked. It was kind of an easy choice. But then from there, I was thinking about prosthetics or tissue engineering, which I was very passionate about. But once I tried tissue engineering and finding out that yes, you built your tool, which is amazing, but then you have to understand it. You have to understand how it works, how to replicate it, how to characterize it, how to make sure that all the processes are repeatable, and so on and so forth. So I had to analyze it deeply, and I fell in love with the analysis. So I realized that all my further steps, so during my PhD and my postdocs, I was rushing through the experiment because I really wanted to analyze the outcome. So in the end, I decided I was going to be a data scientist and not do the experiments anymore, and just get better people to do them, because I was kind of sloppy trying to make it work as fast as possible and then do what I was really passionate about. So that's what brought me here.
So maybe I'm going to date myself here. So I started working at Schrödinger in 2013. And so in 2013, this was before ImageNet, the hottest new ML technique actually in the world was naive Bayes for Google email spam filtering. And most of the jobs use this before like the whole ML informatics boom. And so like most of the jobs using ML were just ads. Ads. Can we get slightly better placement for these ads? And I just, well, that in defense. And I just knew, I don't want to do this. I want to get into something else. And so, yeah, I started working at a life sciences company, mostly because I thought it was cool. I knew absolutely nothing about it, and I knew I had zero street cred to actually have anyone listen to any of my ideas. And so I then spent many years building software just to get the credibility, so that people would start listening to ideas on how to actually utilize this data to have better outcomes. But now, you know, everyone kind of more understands the purpose of ML and AI, so hopefully it won't be as hard going forward.
That's amazing to hear all your experiences, whether getting into data science or AI ML was intentional or you just fell into it. It's great that we have a lot of interest and many different pathways to get to certain points. So since there's been a recent like boom and explosion in data science, artificial intelligence, machine learning, how have you seen those technologies disrupt work at your industry, at your company? How has it changed things? How has it, like what are the trends that you kind of see in your industry and specifically in your company or organization that you work in?
Well, I can go from this side first. Let's do something different. I wouldn't call it a disruptor, honestly. I would call it another tool in our ever-expanding tool chest for how we can solve and approach problems. I don't think it's necessarily any better or any worse, and it should be evaluated with the appropriate trade-offs. I think a key goal is how to trust the analysis. That's a big term that's very important. If you build a great model and you're highly predictive, but you can't communicate to that scientist is actually making the decision to synthesize a molecule to trust your prediction, then they're not going to do it. So it's another tool in the tool chest. A lot of the work comes down to trying to teach other people how these techniques work. They're not magic. They're not this, black box thing, and what you can expect from them, even if they don't fully understand all the implementation details that went into building these things.
I think I can just echo what you said, and very beautifully put. But yeah, well, I want to also add that, for instance, what I do would not be possible to do without machine learning or deep learning, because the two cells I'm trying to phenotype, or the two groups of cells, look the exact same for a human eye. So just thanks to AI tools that we can dig deeper and look at things that we cannot, or patterns that we cannot see with our eyes. So in my case, I would say that adding these tools is just like adding some new ways to like predictions and like or approach drug discovery, which is completely novel and could unravel something that was not possible to do before. And yeah, I mean, I want to also stress out what he said already, that of course, like, it's not that you take a machine learning model, you apply it to something and then you get good data. No, you have to understand your data, you have to know what you're doing, and you have to be very careful when you explain what you did. So unfortunately, it's not true that if you use machine learning, you'll find something. You have to dig into what you're doing and really be careful when you take out the results.
Yeah, I agree with both of you guys. It's definitely there to assist you and there to help you in ways that is going to add value to it. So I think of it as like an assistant. Really, I'll give you the example of ChatGPT, right? We all heard of it. I think we've all used it to some degree. So MSK has something called MSK Assistant. It's also GPT driven, right? So you can just imagine how right now it doesn't have any scientific literature, and that's what one of our efforts is to fine tune it to scientific literature, fine tune it to genetic data, fine tune it to MSK specific data, right? So this is a tool that's going to help the doctors, the medical doctors, right? to search for drugs, ask the GPT, ask the chatbot, what are some drugs that this patient has, right? So this patient has this sort of cancer, what are some drugs that you can suggest? And pull up some drug names. And then even the patient can also have access to school and even look at the drugs and start diagnosing themselves too. You can go even further with that, this patient has this sort of mutation because according to the sequencing data. And then it'll find like a drug that's like, in clinical trials that's targeting for that mutation. So it's a way to help people to get fast answers. These sort of tools have different personas, and I think you should think of it as like a persona of someone that's trying to get a fast answer at an accurate rate, because sometimes ChatGPT in the beginning was giving not so much accurate answers, and it was giving, wrong answers very confidently. So, but now it has become better, and it is improving. So it's supposed to give you, fast answers, accurate answers at a fast pace and accurately. But then the deeper stuff, that you kind of have to defer. That is going to be up to the experts, right? That's why you're studying it. That's why you're working on these projects, so that way you can understand something deeply in which a model won't be able to. They'll help you get there. Help you be on the path of getting closer to solving your problems, but it won't solve your problems for you.
I guess there's two interesting directions I can go there. I can amplify a bit of like it's been communicated here of it's a added tool in your toolkit, right? There's a way that it's useful, and if you abuse it, it is not great. Early iterations of it does not incorporate great literature, and you have to build toolkits on top of it or build filters that end up understanding like, does this really make sense? And there's questions of, is it rules-based or is it data-based? The other extreme, more for my side of like, we're deciding to invest on early stage companies. How much of that is real versus, oh wow, I have to filter myself. Fill in the blank, people. But like there's some amount of people who are like, hey, I have great new AI. It's like, that's just a regression. It really isn't AI is the way that you think it is. And in the same way of like some way of it that's becoming exciting for investors and the news is that it's defensibility, right? It's as if people are starting to discover a new language of communicating to these sorts of databases to ask questions and get answers out of it. And so you're hearing trends of prompt engineering, and there's people who are thinking, okay, what's the level beyond that? Making it easier for other people to access that. So definitely in the biotech space where there's lots of literature put out there, there's been ongoing questions about the quality of that literature, right? There's lots of people who are having great publications retracted because they're actually not that great. Dark news that people whisper about, but no one ever inputted it in the internet, no one data crawled it. And now we're like, oh no, we really don't know this thing that well. So there's like some fears of like, are we getting locked in false ideas as well? But that's just me being kind of a scary person. So I'll stop.
Yeah, interesting perspective for sure. In terms of this type of technology is permeating different aspects of different industries and different aspects within the life sciences. One important consideration is the ethical considerations of how the data is being used and portrayed, and maybe some people might use it for nefarious means, or they might create models that are not equitable for everybody. They might use data from a specific population and represent that for everyone. Could you talk more about that and how scientists, as scientists, how to consider these when you're doing different investigations and speaking to other stakeholders?
I want to put you on the spot because you're at like MSK. You actually have to worry about this stuff.
The stakes are definitely high when it comes to life science data or the medical field or any sort of, basically the life science field in and of itself is a high stake space. There's several things that goes into it. You have, like in terms of ethical side, you have the data privacy. So you want to make sure like your data is being used for what is intended to be used for. Because if that is misused or it is like in the wrong hands, then that can cause mistrust in the tool. And then if it's causing mistrust in the tool, then the entire technology is going to be that way, right? To also add on, so whatever is being built that's AI driven, you want to make sure that, okay, so whatever being built AI driven, you're using it and you have to be aware that it's going to be biased to some extent, right? It's not going to be objective. So, you know, with that in mind, you have to take into account, like, the answer is the result that you're getting back is not a fair answer, it's not really following fairness. So, you know, building your model or building your application in a way that's taking into account of all sorts of factors or all sorts of different fields, different sort of different variables, that's important too. So I think there's data privacy, then there's AI fairness, and then that kind of, if you combine both of them, hopefully can lead to a more, a better way of using the product or using the AI technology in a high stakes setting, so that way one can trust it. Did that answer the question? I don't know.
Yeah, that's it.
Okay.
I can go next. Yeah, I want to start with a little anecdote of something that happened to me a couple of months ago. I was speaking with my uncle, which is over 80, and he started saying like, oh, I think AI is evil because it makes us buy things we don't need because it personalized ads. And I'm like, no, AI doesn't do that. It's like people using AI to do that. No, I don't agree with you, AI is bad. Like, no, I mean, there's no agreeing. Like, AI is not what you're saying. So, yeah, echoing this, I think that there's a lot of misconception about AI. That's the tool that is stealing your data or trying to make you vote for a certain party or something. But no, that's like how people use it. So as how she mentioned it, like it's very easy to bias a model. So like it's up to you, to the user, to like who builds the tool. That is important to like respect all the rules that are there. So of course, like avoid biases by balancing the data, or even like privacy. Like you don't want to donate your material. Like I talk about material because we use cells donated from people, but like they have to sign what they want us to do with it. So if it's AI or it's not AI, you still have to respect their wish of using their material or their data the way they want it to, or they intended it to be used. So I think AI has to be treated in the same way. It's just that it's very powerful. So if you don't follow the protocols correctly, it's very easy to do big messes. So that's why maybe you have to be extra careful, but it's still up to the people that build the models to be careful about how to safely use them.
Yeah, these algorithms that we're talking about, they're distribution matching algorithms. It's a human who then takes that match distribution and tries to optimize it for some sort of goal. I often say building software is actually one of the most human things you can do because it's often a human who uses it or gets the output of it. So as a human, you have to realize, what is this distribution? What am I trying to optimize for? And then do all the things that we do as humans to be moral.
How do you reduce bias then, like personal bias or team bias, when you're creating these models?
Well, so there's two sorts of deeper elements to that question, I guess, which is A, bias is such in the data that's going into the model, right? What sort of experiments you're doing that's actually informing like what's going in there and how you choose what's being in there and what's being inputted. And that's like more human level data, right, to some extent. Then there's the other bit of data of like, hey, what am I sampling? What sort of tissues or chemicals? And then, actually, there's a third one that comes to mind because of a crazy paper. You all hear crazy things from me at times, I'm sorry. So plenty of you might have a problem in life, right? I see a number of classes. I have classes I'm in contacts right now. I might be interested in finding something that could improve my eyesight, something that can increase the tension in the muscles in my eye that allows for the recurvature, meaning not to wear glasses often. Okay, cool. That's a great thing that I could maybe prompt into a system and find drugs that are very selective. Well, there's a paper a few months ago, within the last year, that basically turned it around and be like, cool, what's the most poisonous poison I can find? Seriously, got lots of attention. And basically they found like toxic nerve agents, and they found things that are probably 10,000 times more toxic. So back to the ethics question. We have lots of data on bad things out there. Do we let people have access to it? For what purposes? Who knows if we find some very angry scientists while they're quitting their program and being like, I wonder if I can find something that looks great as a prodrug, but when it's metabolized, it slowly poisons people for 30 years. Hopefully that's not happening, but as an ethics question, that's something that some people, admittedly at edge cases now, slightly worry about a bit, of like, what are the outlier bits of data that we're not really thinking about at the moment? And you can't really be, there's no perfect golden answer to it. You just need to be aware, right? How do you stop crimes in your neighborhood? You don't put everyone in handcuffs. You just actually get to know your neighbors.
Yeah. So yeah, actually where you were talking about, it just reminded me of the Biden administration just released AI code of ethics, like code of conduct on how to do your AI, or is I think mostly targeting the industry, mostly targeting the tech companies. So there is a code of conduct out there in terms of like how you should be able to access data, who has access to data, what parties of which type of parties can, when they do have access, can work with the data. Just because you have the data doesn't mean you can actually work with it. In terms of data handling, I think that code of conduct pretty much hopefully captures that, or is able to help with that, assist with that. And the other thing about like use cases in terms of like when you just if some mad person would wants to use the data for bad intentions or whatnot, it's like those type of regulations has to come together collectively. I think we all have to collectively, as a community, and this requires like non-data scientist people who don't have a data science background, asking just someone like, hey, what do you think of something, just kind of crowdsourcing these sort of use cases, and as a collective community, come up with some sort of formal process that can regulate those, that can regulate and how to handle and use AI in a much more careful fashion, in a much more safe fashion.
Yeah, hopefully everyone here is going to use AI and data in a very responsible way, I hope. In terms of communicating to the public and working with different stakeholders that might not well versed in AI or data science, computer programming, not a techie at all, let's say like a hardcore experimentalist. How do you negotiate like conversations with them for them to trust the model and trust the data, and how do you navigate that type of conversation either with non-technical stakeholders, the public, or hardcore experimentalists?
I guess I'll go again. So I guess for the scientists, like for the bench scientists, or just like the bench researchers, or just anyone who doesn't come from the background, if you can show results, like some sort of promising results with good statistics and probability, like the chances of this being a positive thing in your project or in your work, that, at least they'll talk to you, at least they'll start the conversation, and at least they won't just give up on the idea or give up on you working on it. I think that's one avenue, one approach to kind of show like the positive thing, to kind of show the result is a positive result, and I have to keep working on it, and I keep showing it to you, we keep doing this, it's gonna be even better, right? Because if you stop working, imagine if you stop using AI right now, really? Like if we stop using technology right now, will it get even better? Like we have to keep using it in order to come across these scenarios and these problems, so that way we can troubleshoot them and then get better and improve it.
So that was one side of the coin, which is the value side. I think it's equally as important to talk about the cost side, and that's the cost of actually using these techniques. If every time an experimentalist wants to use this technique, they have to email you, you have to hop on a phone call, you then have to chat about it, then they have to wait till you run your analysis, and then they get the results next week, that cost is way too high. So it's both the value, like this is super valuable, it's adding value, and there's frankly, you have to make it easy for them. You have to describe it in a way that they understand. They can immediately interpret it, make it as short as possible because these people have things to do, and get fast turnaround times. And the way to do that is highly automated and understanding the domain and understanding what's important to those people and stakeholders.
That's a good way to.
Oh yeah, I just wanted to mention also, like all through, I agree with everything. Also trade-off, meaning that I come from a place where I actually built the data science team, and most of the people were analyzing manually. So at first it was like, oh, but here one cell is wrong if you do it automatically, but if I do it manually, it's better. But then they come with like 10 plates of cells, which is like millions and millions of cells. They're like, okay, I might have around 5 to 10% of error. Like, okay, that's fine. I cannot count them manually. So at some point, when the work that they have to put into doing things manually and more controlled, then becomes like too much of a work, and then they have to trust you, and then you can show. I just echo what they said. So like you show better results, you show that you can actually go beyond just looking at 5 cells, but you can do much more. Then at that point, it's very easy to convince everyone that it's actually a good tool to use.
So, and then actually there's a fourth avenue as well, which is, not the dichotomy you put forward of like experimentalists versus data scientists. It's an ecosystem, right? Like if one person is doing everything and you're the lone person solving everything, you might have one answer in 70 years because you're trying to figure out how to write things and also like 8 different languages so people learn what you did. You have to trust working with others out there, right? And it's, at least in the sciences, it is sometimes hard but getting easier for experimentalists to work better with some data scientists and data scientists, AI, ML people to understand better, like this is the experimental data I can get access to, this is the rate it is, this is the sort of thing that can actually scale up and be useful for me. So advice to the crowd here is just like, figure out what elements of your skills are immediate strengths, which elements you want to grow as a person, which elements are just like, I trust that someone else will do this, and I have to learn how to interact with them and interface with them. And then take some amount of time to translate, which also means getting over your own fear. And I have to do this myself, of just like, I'm gonna sound like an idiot 90% of the time. I mean it, I believe I sound like an idiot 90% of the time when I speak with others. Because I'm just like, here's a random idea, I hope you can catch it, I hope you can kind of play with it, fix it, and send it back to me. And then it becomes conversation. And I feel like that part gets hard a bit when some people try to approach this idea of like AI, ML, and life sciences, where they think they need to approach it with perfection. And that I think is actually a big barrier for people trying to do things.
Those are good advice and some good insights you can bring into your careers in ways that you think about that. So I want to open up the questioning to the floor, to the audience. Yeah.
Yeah, it's going around. Thank you.
with with AI, it's a relatively kind of like the advancements are relatively new, and with data science and stuff like that, it's like evolving. So like, my question is, for example, when I started using ChatGPT, that's about as AI as I got. It as a person who studies computer science, it kind of changed the way I kind of like approached my field. So like, I saw like it kind of immediately changed the way I did things. For example, like I wouldn't Google Stack Overflow or anything like that. It kind of like really changed the way I approach things. So like, have you guys kind of seen it in your field where you're like, wow, like it really like completely changed, switches the dynamic, the paradigm? Is that something you've seen like in real time?
Really?
Sure, go ahead.
I don't have an answer for that. I just want to amplify that question, actually. Sorry. Well, no, the two things from that thought is, A, do we trust the answers that we get from some of the things? Like, how do we like pour in data into it, and how do we like continuously have that loop? And then how do we really know that like, wow, things are now 10 times easier? I have that question a lot of the time, because like reproducibility is an issue, right? You ask something on ChatGPT, you ask your friend, hey, ask the same thing. Maybe like 80% similar, but there's differences. So like,
You can set temperature, right? If you actually build these things, you just set temperature, and then it isn't different. It is consistent.
Yeah.
Go ahead.
I'll say it is consistent. These things have APIs and pinning, so they are consistent.
Well, so I think so he was giving an example about like, stuff that you wouldn't Google anymore, you just use ChatGPT. So like the Stack Overflow, yeah, sure, let's say if I want to write a sorting algorithm, I'll just ask ChatGPT, write the sorting algorithm, and it'll do it for you. Now, ask it to implement handlings. It won't do such a good job. I feel like, again, some easy stuff, some fast stuff, it could probably do. Stuff that you won't Google, stuff that you would have, gone to Stack Overflow, you just go to ChatGPT. Sure, that will cut down your time, that will cut down your, that part of your brain to not think anymore, but when it comes to that deep thinking, where you're going to be writing an advanced algorithm with more loops and more conditions, I don't think it's gonna do a good job. And it hasn't either, and I remember in the beginning, it really did give some awful answers.
So I'm going to say something different. I think everyone here should read a paper about using vector databases and prompt injection based on context-aware snippets. I think pre-training or retraining these foundation models is probably going to happen less because it costs a boatload of money. But in using proprietary domain-specific information on top of semantic search with prompt injection or looping on top of it can accomplish a lot. At Schrödinger, we already have one of these things that has access to all the literature and papers that we've downloaded that you can ask pretty complex scientific questions. And that sends you to the papers that had it, or you ask it how to write code, and that links you to our own internal code bases and where those functions are. These things exist and they're not that hard to build. The question is, who's going to build them and how will they interoperate with each other? About does it change stuff? People move slow. They do, right? Like there's going to be early adopters. Early adopters are going to be okay with these things hallucinating or getting improper summaries, but results are going to win out. Remember back in 2004 when all your teachers, when my teachers were like, can't use Wikipedia, Wikipedia isn't trustworthy. But then we learned what's trustworthy about Wikipedia and what's not. And we changed, Wikipedia didn't really change. And that's what's going to happen with these tools, is they're going to get better and we're going to learn how to use them better.
Yeah, just to add on, I think what would help with these tools is just, because we're talking about ChatGPT, sometimes it's going to give the answer so confidently that you just believe it, right? Perhaps implementing a confidence score, okay, I'm 90% confident about this answer, but you might want to check. I'm 80% confident of this answer, you might want to go check. If you give it a metric, then it's something to communicate over and something to help you assess how much you should trust it or whether you should trust it or not.
So you're closing the loop on that thought, which is hey, for first-time users of ChatGPT or other generative platforms and large language models, they're not necessarily being told, hey, there's a temperature function that's being used to actually generate some amount of randomness here, to actually sample a phase space and choose the next correlative prediction of a word here. And like, they made that selection. It makes it easier to have rapid adoption of hundreds of millions of users by not having that barrier up front. But it makes it hard for people who try those early tests and try to get integrated further, deeper into that interface. And it's getting better, but figuring out what that is it takes time. So like definitely like the ease of access is making it better, and how we're all learning what are the levers you can control internally will get more and more important as we all learn it. I think it's good.
Yeah.
I
Go for it, yeah.
can give my 2 cents. No, I agree with pretty much everything. I think it's still like echoing what I said before, it's still a tool. So if you use it properly, if you know that it's not perfect, if you know that probably if you make it right your code, you have to check it, then it's good. So in terms of like how much it changed my life, not that much. I tried to play with it. I mainly play with it. I got some nice results, I got some weird results, but usually it's just like, okay, let's see how it would frame it for me, and then I just build up on it. And just like one fun thing that it made, I asked it if it could make my code faster, and it just chopped half of it. So it was just working for what I was doing.
Hi. So my question is, you all mentioned now that the incorporation of AI and machine learning in data science. What do you think for like an impressionable scientist, data scientist, like with all, I think Karl, you mentioned about understanding the tools and techniques of AI. Do you think it's going to be like challenging or easier for like a new impressionable data scientist now coming into that field with the incorporation of AI into data science?
People are looking for them now, right? I would say 10 years ago, major pharmaceutical companies would have like a chemoinformatics team, but they probably wouldn't have the data science team, I believe, and someone could correct me if they know more than me here. And so, yeah, there's general availability, but there's still large institutional barriers in large companies around privacy, data secrecy, which is all important stuff. So having a strong programming background to be able to access these disparate data sources, actually run your analysis, is one of the key tools, as well as the stubbornness to keep fighting through these blockades to get access to the data you need. Yeah, I don't know if that answers. Yeah, I think the future's bright, right? I guess that's my summary. But the bar is also getting higher, right? You can't just run like a lasso regression and turn it in and be like, I'm worth this, right? You actually have to be able to wrangle the data, understand it, do intense visualizations, explain it, in addition to running that lasso regression.
No.
Well, so one of the things that I've mentioned more secondhand-ish as well is, so two sides. Inside of corporations, inside of certain groups that you join, just like how you have a certain friend group and you have inside jokes. I'm trying to be fun about it. Certain groups will have certain ways of communicating, so figuring out how to kind of break it in takes some amount of time, which requires some amount as well of these groups participating outwards and communicating how they're doing their work. So in life sciences, there's a range of important conferences out there like ASCO. Neuroscience, there's NeurIPS, where plenty of people will share what they're doing, and they're getting more and more willing in the past few years to share some of their data, share some of their insights and visualizations. There is an open question if people will continue to be that progressive about it, or if they're going to become more insider baseball again because of the current environment of investments. So there's a certain question of like, does that trend continue? I'm optimistic where I feel like there'll still be higher turnover, there'll still be more people getting in the field, there'll still be more ideas coming from, universities and external open source like communities where people will share their information. But there have been some concerns from some groups of boomerang candidates where, oh, you came from a great group at Google's AI, let's take you to OpenAI. And after a year, they go back to Google. The information I've heard is that they just could not speak the OpenAI language. While they were great at conferences, they were great at certain ways, they just were not able to integrate with the rest of their team. And that's a barrier you're going to see in like human society in general.
Yeah, I agree with what's being said. So I do think, I feel like everyone is interested. Like everyone has that interest in the back of their head, just because it's everywhere, right? Like whatever you use has some sort of AI technology, some sort is incorporated in some way. So I think I feel like in terms of again going back to like this whole communal thing, this whole collaborative thing, being able to be transparent. I think the transparent sense that like, okay, not only are we, it shouldn't be a black box when it comes to like talking about the tool or talking about the science, right? There's also the field of AI explainability, being able to explain it in a way that's, more, not lay language, but more, in a more naive language, or more language that can, that everyone is able to understand and comprehend. I'm sorry, is that answering the question?
Yeah, because I was asking if the understanding the tools and the technique, if it's going to be challenging for a young data scientist coming into that field, and how it's going to be the approach for them understanding those.
Yeah, I think that's how the field of AI explainability kind of helps do. Like it helps trying to keep the workings of the AI technology, like whatever's behind the technology, not look at it as a black box, kind of like unbox it and be able to explain each part of it, because sometimes these models do whatever they're doing and you just have no idea what they did and how they did it, right? So the how is what AI explainability in some ways tries to, put effort into. But that also goes for people who are just not ones who are using the tool and are like studying it or working with it, but ones who are just interested too.
Hi guys, sorry, did you want to go?
I mean, it's okay, I just wanted to say that it's a field that is evolving very, very fast. So even if you are in it currently, then there is this new tool that revolutionizes everything. So you have to like be up to pace and study it and try to understand it. But it's also true that being this wide, then sometimes it's also fine to like sectorialize and just go for like what you're interested in. So you don't necessarily have to know everything, because that would be a lot. But like it's happening in all the other fields, like in biology, you don't know how monkey works and how stem cells work. You just choose what you want to dig deeper into, and then you just go with it and become an expert in the field you like the most.
Okay, sorry. So I really enjoyed all of your opinions and insights in the industry. It was great. And I want to talk about something that all of you kind of touched, which is the data problem that exists in life sciences and medical data. So by practice, I'm a biomedical engineer. I have a degree in an undergraduate in biomedical engineering, and I'm doing a master's here. So, and my approach to AI has been like on the outside, which means that I look at all these cool things that OpenAI is doing, Google is doing, and I try to apply to my BME data sets, like lung pneumonia data sets, or like breast cancers. And you guys know that it doesn't work. You put it in the first time and it's like a 5-6% that comes out with the accuracy and stuff. So my question is, what is being done to basically solve the data problem? And is the life sciences AI subunit gonna move as fast as the general AI that is, and data science that's already there?
So I'll go first. So to answer your question, I think there's two ways to look at this. One of them is actually working with the algorithm, working with the AI algorithm, making it in a way that's able to, or just kind of programming in a way, trying to incorporate the mathematics, the logic, program the logic in a way that I can understand this sort of data. That's one. So there's a few projects that I'm involved in that is, initiating, that has initiatives towards those efforts. Just working on AI algorithm, right? So that's more on the theoretical side. That's going to require mathematical theory and probability statistics. So it does take time. It will take, in my opinion, like a longer approach to really outdo like all the problems with the data that doesn't work for the model. And then you have, working with the data, being able to, there's a lot of data wrangling, a lot of data processing. That is always an issue in the life science world, just because nothing is standardized or formalized in a way that all parties follow when it comes to biological data or life science, because life science data consists of the genetic data, the biological data, and then you also have clinical data, which are two different formats, and they're just not standardized. It's like they're not, I don't know, none of the parties are talking to one another. There's not really a consortium that I know, to my knowledge, that kind of come up with these nomenclatures, or come up with these standardization, right? I went to the same issue. This issue is actually even more prevalent in the industry than in academia, in my opinion, because when I was working at Genentech, my role as a data engineer and working with the clinical data was such an eye-opener to like how much of a mess it is, right? And it's just unacceptable because you're working with patient data, and you cannot mishandle it in that way, or it just cannot come out to be like that, right? So, sorry, just kind of sidetracked there, but yeah, just to kind of touch upon, there's two ways to do this. You can work with the data, but that's always going to be a problem. And we come up with some sort of consortium, there has to be some sort of like group out there that kind of that comes up with these nomenclatures, that comes up with these metrics, and we all just have to follow it. Like the entire world just has to follow it somehow, right? Or you work with the algorithm. And that's, in my opinion, more interesting, and I think it can outdo all of our problems if we give it the time to, really work with the mathematics, work with the logic. And what was your other question? Do you have another question?
I was just asking how long life sciences, AI and life sciences is going to take to catch up with the tech world AI and what they are doing.
I think the tech world is ruling AI, is leading AI to a point where, I feel like I think the fact that we're using, the tech companies are using a lot of AI and developing a lot of AI technology, I think somewhere or along the lines, there is going to be opportunity for us to discover a whole new other technology. Like, I don't think it's gonna take over many jobs. I think it's gonna allow more new jobs that are not here today will be created. Like, I'll give you an example. So for instance, when film photography came out, like black and white photography first came out, just a quick example. When the black and white camera came out, right? Painters who paint full art, what should I call it, human art?
Portraits.
There you go. I'm sorry, I'm not an art person, but yeah, portraits. Portrait painters, right? They thought they were going to be out of jobs. Just because, here you have this camera who's taking a live picture, and it's much more real than this portrait art, right? Out came the invention of abstract art. That's how abstract art was invented, because they had to find another way to learn to do their painting. They just developed a technique to do their painting. So that's what I think is going to happen. I think some new technology. I'm very optimistic. There's some new technology out there waiting to be discovered. Some new job out there that's going to discover that technology and use that technology. And yeah, that's my 2 or 5 cents.
Yeah, I totally agree with the second part. I just wanted to say for the first part that I don't think there is an easy answer to the question, like why sometimes the model don't work. It's not always the model or always the data, it's a combination of many things. So first of all, you have to identify where your noise comes from. Actually, I think 80% of my job is to make sure that the data is good, it's balanced, and like I design the experiments, so I have to make sure that I have enough like young and old individuals and they are matched. Otherwise, you don't know what you're looking at. You'll see a signal, but might be some nuance that you didn't account for. And sorry, today I'm full of anecdotes, I don't know why, but I have this new one that basically I know at NYU where I was working, they were trying to apply, it was early stages CNNs to read radiograph images. And they were seeing that this network had like 100% of accuracy in finding, I think, lung cancer or something. I was like, that's impossible, like doctors are 60, 70%, how is that possible? And then they managed to reverse engineer that network and they realized that all of the patients had a tag, while the non-patient, the healthy control didn't. So it was very easy for the algorithm to just identify the tag. And that's why like, it's very important to know your data and make sure that you accounted for everything before you throw an algorithm. And maybe it doesn't work because there's some noise you didn't look at, or maybe it does work because there is some noise or nuance that you didn't look at. So I think it's very important to make sure that the data is in good shape and pre-processed in the right way. I mean, I work with images, but if you don't do a proper pre-processing, nothing works, and so on and so forth.
Real quick, there were two major consortium attempts to solve this in the small molecule space. There's the Atom Project and Melody. They both attempted to solve this using differentiable privacy. So the way this generally works in a deep learning model, and they did in this basic form, is you train one mini batch at one company, then you shift the weights, and then you just kind of round robin around these major pharmaceutical companies. The downside is because it was so long and bureaucratic to actually organize this thing and to figure out data security and figure out data privacy, they're not using state-of-the-art models, and so they got poor results. And neither of those consortiums, to my knowledge, are still in operation. So there have been attempts, but I don't know, part of doing this work is touching the data, and it's a lot harder with these differentiable privacy techniques. You don't know what's actually happening.
And I'm going to pile in on their two last elements. So one out of MSK actually, and a few other institutions on the east side, is looking at a back catalog of histopathological records and using that. So on your question about like use of AI in life sciences and like how it's kind of shitty when you compare it to like the tech world. To some degree, if things are done well for life sciences, and this goes back to, do I trust the experiment or not? Is it tagged well or not? Is there a weird artifact of a ruler, and the ruler is the diagnosis of cancer? There's a lot more data that's structured from like thoughtful scientists. How it's probed will matter a lot, and there'll probably be some insights of how you manage that will actually feed back into the tech world. My own personal belief. I can be proven wrong. Please prove me wrong. And then on some of the other challenges there as well is like, so for the MSK example, is like, I think a dean lost their job because of that startup. I cannot remember the name at the second, but if you look up the New York Times article, there was questions of like, oh, it's really weird that they got a special license, but no one else ever did, and they're excluded from it. So it goes back to the much earlier question of ethics, right? Like, cool, an institution has privileged access to a biobank, and they license a startup to only their work, and no one else can collaborate on it without going through this for-profit middleman that was created from a nonprofit database. Cool, so someone's making off of a lot of tax-free dollars. I'm not saying that like things need a motivation to actually move out there into the world, but there has to be some amount of balance of privacy and transparency. No perfect answers. And I love the artist analogy, and I will go on to that on a completely separate topic, not on mic.
I want to thank everyone. We're running out of time, but it's very interesting to hear all your perspectives, and thank you for taking the time to talk with us. Could be sure all the attendees really have really enjoyed your insights and everything.